So I'm just gonna use decimals to graph it. I think that'll be easier, but I can solve. I'm gonna solve where the y-intercepts first. So it'll be y. Are you sure you give me questions, right? Minus 3 is equal to negative 1/2 x. Is that right?
Mr. K, can you zoom?
Oh yeah. So and then 2y minus 6 equal to negative x. So x is equal to 6 minus 2y. So I'm gonna set 1/2 y squared equal to 6 minus 2y. So that is equal to y squared equal to 12 minus 4y, I think. Y squared minus plus 4y minus 12 equal to 0. Y minus 6. A y plus 6 and a y minus 2, I think. So y is equal to 2 and y equal to 6. So somehow negative 6, yeah. Somehow that's going to be negative 6 into 2. Now I just didn't figure out what's the right function and the left function. So I'm going to use decimal here because I don't want it to sketch it. So x equal to y squared. What is x equal to half y squared? And I'm going to go from here. And then what was the other function? Y equal to what?
1.
1. Okay.
And then y equal to negative 1/2 x plus 3.
Negative 1/2 x plus 3.
Yep.
So it seems like negative 6 to 1. Well, actually, it's to 2. Do I do something wrong? Oh, to 2, yeah. Negative 6 to 2. So this is. And they say it's from where to where? Wait, why do they say y equal to 1?
That's one.
Oh, why did 1? Then they were interested about this area here. They were interested about this area here, right?
Well, I don't know which one, because it's like you're just cutting it in half, and it's asking for the area enclosed, but there's two separate areas. So I'm not sure. Like, I don't. My question is, how would you know which one they're asking about?
Do they say anything else?
Mm-mm.
I'm pretty sure they say something. Hold on a second. Um, do you have the question pull up? I don't have the question in front of me. Number 6. Yeah, how would I know which one? What'd you say?
Oh wait, I was 6th period. I was thinking that. Yeah,
What is that?
It's Parkway. Apparently we're learning it this either this week or
Yeah. I actually don't know which area they're talking about.
yeah, they
Bangla.
probably should have been white.
Huh?
I don't think there should have been white.
Yeah, I think y go to wait, y go to 1? Are they talking about the top area or the bottom area?
That would be just a bad question.
I think you should not have y go to 1. I don't think they should have y go to 1. I don't know why they have y go to 1. Nobody asked me this question. Okay.
Maybe it's separated.
Yeah, it's separate, but they all bounded by 3 separate graphs, so it's not really
Yeah.
so so let's just assume that they are looking for here.
X equals 1.
X equal to 1, that's the same area overlap. No, yeah, that's same area overlap.
Yeah, it's up to. Or no.
So in term of this, you don't want to do it in term of dx, because if you do a dx, let's just say if I don't have this, right? I don't have this black line here. And let's just say we want to find out the area between here. I think that's probably a better question. If you do it in term of x, you have to cut it to 2 parts. Well, actually, you can't even do it actually because they're not even. So you can't really do it in term of x. There's no way for you to do it in term of x. Oh wait, yeah, there's a way. So you're gonna do it like this part,
It just times 2.
and you have to multiply by 2. So that becomes this part, right? Does that make sense? So just do area of curve between 0 to 2 and times by 2. And then you're gonna do area between the curve for 0 to 2 of this one is gonna be square root of 2y. Yeah, square root of 2y between 0 and double. Plus between 2 to 18.
It should be 2.
So you're doing it in terms of x. You wrote down square root 2y.
Yeah.
Okay, so yeah, yeah, this is x, yeah. My bad. Square root of x. So that's gonna be square root 2x, right? Okay, so that's gonna be 2 times of that, plus from 2 to 18, and that's gonna be top minus bottom, and the top is gonna be negative 1/2 x plus 3 minus the bottom is gonna be negative square root of 2y or 2x dx. Why is negative? Because there was a positive version and there was a negative version of it. So therefore it's gonna be, it should end up to be plus. So this is much more complex. Now if you do it in terms of dy, then all you gotta do is from -6 to 2. And it's gonna be right minus left. So right is gonna be y minus 3 equal to -1/2 x, and then x is equal to 6 minus 2y, I think. Is 6 minus 2y? So it'll be 6 minus 2y minus the bottom part is going to be 1/2 y squared and dy. So this you can do it in one integral, Jared. Because you do right minus left. So the way that you cumulate area is going to be this way. And you only need to do one integral instead of do 2 separate integrals. Which is going to help you, calculation is much easier.
Oh, yeah.
Does that make sense?
Yeah.
So I will choose the one that's easier. Now, some people are asking, is it easier just convert everything to one variable and just do top minus bottom? Yes and no. In the area perspective, it's actually okay because it's only in 2 dimension. But when you got volume, it's going to be 3 dimension, then it's no. So it's get used to that 2 dimension the same way as you do in 3 dimension, and it would be much better.
What if you added the one line? Yes, for the big part.
Huh?
Like if you added the y equals 1 line as a
Mm-hmm.
and you cut out the small part.
I think it would be anything, or you just go from.
You still have to break up to 2 integrals. Regardless, you had to, if it's in terms of x, you had to break up to 2 integral regardless. Now y only had to do 1 integral.
It'd just be -6 to 1.
But if you had
Yeah, that's fine.
You did it?
I think so.
What's your answer?
For my dimensions, 3 by 3 by 4. My money, I got 330.
Got it? Got it? My money was on Luke. You two owe me $5.
No, you backed it up. I heard you.
like the boat.
The boat? He
Yeah.
cannot handle the boat.
You start however far offshore, however far downshore. short, and you
That was
know,
the
at least
problem.
you can swim however fast, you can walk however fast. Like that's the optimal angle.
That one's cool.
Have I learned? Have we learned this yet?
I'm gonna do if
You're good.
yeah.
With what you taught me. You
Yeah.
haven't taught me anything yet. With no.
Rely on intuition.
I'll learn intuition.
It's nothing you haven't. It's not like concepts you haven't learned yet. Or
It's-
it's not like
It's all the knowledge you have. You just
Invigilator is enough.
It's not.
it's not really real. But it's an actual world application. Like if you want to build like oil rig in middle ocean, right? And you have to have the oil shipped to Atlanta, right? So it must be like let's just say in middle of like Caribbean Ocean or whatever ocean is. It's called Caribbean or no? The one in middle of Florida, what is it called? Oh, Gulf of Mexico. So let's say it's in the middle of Gulf of Mexico. You have an oil rig, and you want to ship all your petroleum to Atlanta. So how you want to build it, like the pipeline? How would you want to build it where? Because it costs a lot more to build a pipeline inside the ocean than in land. So you want to find out what's the optimize, how much you have to build on land and how much you have to build on ocean. But okay, so here's the things I want you to copy down. Disk method and the washer method. The reason why I cannot wait to get this week finished because after this week, then I share the BC material so I can teach to everybody instead of just teach to Jared. Which is,
And we're gonna slow down, right? Or still?
no, we're gonna keep around
Have a test before
the same speed.
What you did?
You gotta cram all of these in one quarter.
We're gonna have a test before break.
Yeah, before the final break.
This week.
Yeah, you're gonna have a volume test.
And literally test
Probably, yeah. Originally, I was gonna put Thursday, but I don't think I can make it Thursday because Wednesday I'm not here.
Yeah, and there's no point
I see.
making it Thursday, because then on Friday you're gonna teach, and then we're just gonna.
That's true.
So we should make it Friday.
You're not gonna be here. Say.
Wednesday because I have this stupid training.
It's not stupid. It's for mental health, student.
I only cause mental health issue. I don't fix them.
Probably make you have more like
What happens if you don't
You
go?
can learn how to break.
Everything's reverse psychology.
I told people don't take this class. I did give a warning. It's good. It's bad for mental health. I say that first day, right?
Yeah, you got it first day and second day and third day.
And like weekly.
Yeah, pretty much weekly.
It's not good for mental health to take calculus.
Did Sean drop?
Sean Miller,
Isn't he like homeschool?
he just always sick.
he left a long time.
Yeah, because like he parks right next to me, so I haven't seen his car in like weeks. I'm just kind of like,
Yeah. He bought a parking pass just to leave.
Damn.
Yeah, you should have just asked him for the parking pass.
no, honestly, I'm just gonna like park in between both the spots.
Right in the middle.
You should like that parallel park.
I'm gonna parallel park.
Park transfers between two parallel line. That's how I look at it.
Just like
No, I think Sean is he's really smart though.
He is.
He is really smart. He's intuitively smart, like especially like in terms of shape, like volume. He will take care of this very easily, but the algebra skill he's really bad. But visually, he's actually very good visual person. See, not a lot of people can do like this type of stuff. This type of calculation is because a lot of people are not visual. But it's very difficult for you to be visual. What?
YouTube on the time.
At least he didn't come by and kiss you.
That's you.
No, he didn't do it to me. He did it to Jack or something. Diamond.
Oh, no, he's not.
Yeah, he's in my class.
He is?
Is he with Irvin?
Huh?
Is he in Irvin's series?
Yeah. He's doing good actually.
He's in third.
Jack's doing good. Jack's smart.
Oh,
64.
oh, sure.
Her boyfriend though.
Oh,
What's his name?
the
Yeah.
cheerleader.
What does that say?
Yeah,
talking about the second one? Oh.
Okay, so in terms of this,
Don't worry.
I'm gonna talk about this method has two things. Has just actually let me change this. Let me change this to big R.
What? What? Tell me who's my girl.
I don't know.
Bro. I'm 17 years single.
Yeah.
I'm 17.
I can say what's your girlfriend, but it won't be good for stream.
Girlfriend.
No, it didn't. It didn't, bro.
Oh,
Oh,
yeah.
yeah.
Well, Mr. Yates was reading for you.
We already do.
Bro, shut the fuck up. Peach.
Jesus.
Are you serious? That's where the
I wasn't directing it.
He was
towards
not
you.
gonna be. 'Cause that's
Yeah.
all right. So this method here is gonna be r squared x dx and r squared y dy, and that's a big R. That's just one radius. So this method does only have one radius. A washer has two radius, has a bigger radius, and you take it out the middle radius here. And that's what it's called washer method. So r squared x minus r squared x dx, and there's r squared y minus r squared y dy. So basically you can do it in terms of dx or in terms of dy. So I think somebody suggested, can I just switch everything to x and do it in terms of x? It doesn't work with volumes. I'm going to talk about that, why it doesn't work with volume. Because if you're talking about three-dimensional, it doesn't work with, you have to either decide whether dx or dy. It's very hard to do all of these dx stuff in terms of dy. It's almost impossible. I always draw the axis rotation symbol. It looks like this. So I draw it on the way they told you that where the axis rotation is. So that's my first step, and this is my systematic approach. You know, I double check all those things before I write down the answers. So this is a draw the axis rotation. Now, draw a line from axis rotation. So you always draw a line from axis rotation. Either you can draw one line or two lines, because you draw the boundary. Sometimes you get one boundary, sometimes you got two boundary. If you got a second boundary, that means you have a washer. If you have first boundary, then you have a disk. So either you have boundaries or boundaries. So, or you have a boundary or boundaries. So that means you have one bound or two bounds. It's two bound usually like to be a washer for me. So this is just a way I create, because I'm not very smart. I'm not a very visual person. I cannot think like three-dimensional like some of you guys can. But so I create a pretty much an idiot-proof way to solve a problem. If you follow those steps on idiot-proof way, then you should be able to do it. Now, some people can visually understand this, which is fine. But this also help you understand visually as well. Okay, so you have to determine whether dx or dy. Because if you dx or dy, that's going to help you. Says you should do everything in terms of x or in terms of everything in terms of y. Now the fourth step is to determine the statistical washer. That's very easy because you already do that in step 2. If you draw one line, then it's going to be disk. If you draw two lines, it's going to be washer. Now number 5 is determining boundary in terms of x or in terms of y. So the boundary is either a to b or c to d. But c to d is in terms of y, a to b is in terms of x. So you have to understand if it's dx, you have to use the x bound. If it's dy, you have to use a y bound. Now again, if you have disk, then you figure out what's a big R of x, a big R of y. And if it's a washer, then you're gonna figure out what's a big X and small r of x. And big R of y and small r of y. Now don't forget the dx dy at the end, and don't forget the pi, and don't forget the square when you need it. So there's a lot of people forget the square sign. There's a lot of people forget the pi. On AP exam, you don't get credit if you forgot a pi. And on AP exam, if it's talking about volume, if you forgot a square, you also don't get a credit. So you need to have a square. And also dx dy is very important because without dx dy, you don't know which part you take integral respect of. Now this last part is actually pretty crucial. Any type of function is the distance from the axis. So its function in terms of x is going to be from x-axis to the boundary, or the function could be from the y-axis to the boundary. So that is kind of understanding that you guys need to understand. So what I'm going to do is I'm going to show you how to do the first one, and I'm going to kind of guide you through all different ones. So now first of all, we're going to graph y equal to x minus 2, y equal to 0, and x equal to 6. That's going to create a small boundary, and I want you to rotate around x-axis. I want you to try this one before I show you the answer. Now this looks like kind of like a football, half a football, but except this different than last questions that we give in the class. Is gonna be a football is moving 2 units to the right on the origin. So this is just a very simple one for you to practice.
So like if you think about the graph of y squared, like y squared is like square root x, like top to bottom.
Mhm.
So like if you rotate square root x, did you say like it goes like 360 degrees?
Yeah.
Around. Like if you just rotate square root y, it go 180 degrees.
Or you go 360. You
Yeah.
probably divide by 2.
Would you? So I'm saying, yeah. Would you divide that area by half?
No, but you would cut the region by half. So the way you rotate, you will not do from -2 to 2. You will do 0 to 2,
Yeah.
and just do 360.
So now I'm thinking that would like double your thing.
They'll repeat, yeah.
Yeah. All right. Cool.
They'll repeat. So you don't want to do that. And also, I think that will be the same function. Will they? No, they won't cancel out, but they will give you a double amount.
Yep. That's all. I just want to make sure.
So yeah, but it's better to cut the area into half and just do a rotation full. And I think that would be a better way to approach it. But again, like competition question, there are a lot of those.
Yeah. No, just like kind of just idea of it. Like I was saying like there's like the math no only do it 180 degree. I don't know if you know. Like,
Yeah, it does because of the pi r square.
Yeah.
So pi r square is still gonna get you the whole area. But data, I think. Have you learned Shell method yet?
Dude, no. I think we did it like the first day of math competition, but I kind of.
Yeah, Shell method is cool. So you can do it like, you can do something like this, like something like this, like x squared plus 1 graph, and you rotate around the y-axis. But usually you had to cut it to 2 sections. You want to rotate because there's a washer method on the top portion,
Yeah.
and a disk method on the bottom. But if you can do it in Shell, that means you only have to do one integrals.
So Shell finds the same thing, but just a different way.
No, yeah, Shell is using surface area. No, using circumference rather than pi r square.
But it'll still find volume of a shape.
Yeah. So it's basically take this line right here and rotate around x-axis. Rotate around y-axis. So basically one line and just rotate around. So you're gonna have just it's just gonna be a hollow cylinder. So we call it a shell, and that's much better. Okay, so hopefully you guys did it. if I do the rotation, I'm gonna start here again. So this is what I would do. This is my graph, right? Jared,
Mhm.
this is my graph. Is gonna be something like this. And if I rotate, no, if I'm gonna draw from the axis rotation first. So I will draw from here to here. And that's gonna give you a dx. Jared, are you following me? That's gonna be dx, right? So dx is gonna be integral in terms of x. So it's gonna be, you start at 2, you end with 6. So then you choose dx. And you also know that you only draw one line to the end of the curve. So that's a disk. And you say check. And the boundary is between 2 to 6 because that's the x bound. So you start at 2, you end at 6. You follow me so far? And this just the functions, right? This is just a function. The function is gonna give you a square root of x minus 2. So that's gonna give you Rx. Then when I do in my volume, it's gonna be between pi, between 2 to 6, square root x minus 2 square dx. So don't forget the square, don't forget the pi, don't forget the correct boundary, and don't forget the dx. And everything else should be okay. And then you can type in the calculator because I don't really care about how you take an integral here. Just use a calculator. Long as you set up correctly, your answer is correct. Jared, are you following me?
Yeah.
Okay. Now, second one, we're gonna rotate around y-axis. Now, before you do it, I want you to think about what kind of shape will that be. We have discussed in last period, we have to discuss all different kind of shape. Some people say they look like, I don't know, a bun cake. But I don't think this one looked like a bun cake.
Yeah, but it's like, yeah, it's like, I don't, yeah. Just like, one cake.
I don't think it looked like bun cake.
One cake, but it doesn't curve at the end.
Well, the bun cake, the hole is not that big in the middle. So the bun cake is more like this. Like, I think bun cake is like this, right? And like this. And
No, there's a,
yeah, there's a hole, but there was not big a hole.
no, it's this.
Yeah, so there's this really small hole in the center, in the deep center, not like a very wider hole.
I think it is.
Really?
Yeah, it's more like a stadium.
Yeah, this looked like stadium. We were just talking about it. This looked like a stadium. It has a center, and it has to be a Colosseum because it has to be in a circle in the center. It's not like oval in the center. It has to be like a completely circle what to say, Colosseum? Yeah. So a completely circular Colosseum. So and there's people sitting right here, like
No.
Why do you have the bottom?
I think it's. I watched like one cricket game in the past.
okay, so now we want to see if you can rotate around y-axis. I will show you how to rotate around y-axis, but I want you to try it first. And now pay attention, are they dx or dy? And pay attention, if it's dy, they have different boundaries. And they also have different equation as well. So that's why when there's area, I want you to get used to in terms of horizontal representation, rather than just only doing x, which is, I think that's much weaker.
We have to convert it to what?
Do you have to convert to y? Yes, because you will find out this is actually dy.
Oh, it is.
Can you find the volume of donuts?
Yeah, it's spread over the block. You just circle. No,
It's harder than look. Donut is hard.
but that's what you do, right?
Donut has a term. It's called torus. And
Don't we also have to do the bottom, or is it just?
No, we are rotating around y-axis.
Yeah, but isn't there like in the function doesn't go below and above the x-axis?
No, it's only above the x-axis. So in this case, it looks like a Gaussian, like you say, but it's not. There's no below x-axis.
Isn't the donut like 5 squared 2 pi r?
Yeah, donut shape is weird. It's not circular, so it's not everything's like cylindrical. Well, it's everything's cylindrical, but there is.
Yeah.
It's kind of hard to.
I watched a TikTok. It was like you take the volume of the inner radius and the outer radius or something like that.
Yeah, you can do it, but it's kind of hard. Jared, you done? Do you want me to show you how to do it? Okay. So now I'm gonna start from the scratch. So I'm gonna erase this. Right. So this is my graph, and I'm rotating around. So I have this side as well. So this side here, and then the thing is gonna be rotating around here. So it's gonna form like a circular, like a stadium, or Colosseum, or whatever they call it. I cannot pronounce that word. Then what I would tell you is draw a line from the axis rotation, not from here. Don't do it from here. Do it from here, because this is where the center is, and center going from here. This is one line, and this is the second line. This is, I know, it's gonna be it's gonna be a washer. So I'm gonna draw that. First of all, I'm gonna draw all the way to here. And you're gonna say it's different. Yeah, it's different throughout, but it's based on the function, because a function of that is gonna represent the distance from the axis to the curve. And the second one is gonna be a black line from here to here. Now this one's always gonna be the same throughout. So this one you can, if you just do that alone, let's say this big R of y. Why do they call it Ry? Because this is dy. Because this small slice of dy. So if you look at it, it's gonna be if you look at this particular slice, if you look at on top perspective, it's gonna be it's gonna be like this part. This part here. Right? So well, the big R is gonna be the cylinder it's from 0 to 6. So that I know is gonna be in terms of what dy. Now I'm gonna make sure that I have the boundary in terms of y. So it's gonna start at this point, 0, and gonna stop at 2. So it's gonna be 0 to 2, because that was where my y boundary start at 0 and end at 2. Is that okay? And this pi and this dy here. Now, what is the big Ry? But we know this is a washer because it's a cylinder. Take away this region here. Take away this region here. It's cylinder, take away this region. So basically a whole cylinder of radius 6 and take away this red part. And red part is based on this. It's based on, well, y equal to square root x minus 2. So y squared equal to x plus 2 or minus 2. And then y squared plus 2. So that's going to be y squared plus 2. That's the small r of y. Does that make sense?
That's small.
Yeah, that's small. That's the red part. The big part is the 6. And this is a square. It's 6 squared minus y squared plus 2 squared dy.
Wait, actually, I can try 3. Oh, yeah, small. I was trying to think of that.
Because if I just do a 6 square, I'm gonna get a big black cylinder, radius of 6. But I have to carve out the red part. The red part is based on y squared plus 2 in between 0 to 2. And I have to carve that out. If I carve it all out, that becomes a washer. That's why we call it washer. Jared,
You're carving out the red part.
Right. I have a black part and I take out the red part. The red part is the inner radius. The inner radius is not steady. It's constantly changing between 2 to 6.
Isn't the y squared plus 2 function for the blue part?
No, yes, to the red part actually. It's from here to here. So this blue function is from here to here. That is the distance. So imagine if I have a 0 for y, that's from here to here, which is 2.
Okay.
Right? Now if y equal to 2, that's going to be 6, because 2 squared is going to be 4. 4 plus 2 is 6. So that's what you carve out. So it's constantly changing between 0 to 2. Got it?
Right.
Good? Okay. Now you guys got this, so, and this becomes your answer. Does that make sense? Okay, now what if you rotate around x equal to 6?
You use -2?
What do you mean -2?
The function doesn't go negative. Is that what you're asking? No, I'm saying like for the bounds.
The boundary cannot use -2. It's only in this region from 0 to 2. It starts at 0 and at 2. It doesn't have a negative part of it. Okay, so let's see if you can try rotate around x equal to 6. That's a little bit more challenging.
Rotate the same.
Yep.
function?
You know, it's called off-axis rotation. I don't rotate on the x-axis or y-axis anymore. I'm gonna rotate at x equal to 6. We did that with Ramen Song.
No, but like, why is it when you take the opposite?
Why? Like, what do you mean why?
Well, I think this is last. Like it doesn't make. Maybe it does make sense.
I
but-
understand like when you take the derivatives, that gives you slope,
Right.
because why is it when you take the opposite, you go back to the derivative, and you get there? You get this?
No, yeah, I know. Yeah, we never went over why. Like, why do you do that? Why do you do that? Like, Anthony, why do you do that other than not just?
It's easy to just rewrite the function like to make like to just move it over to 6.
Well, no, that won't work. So what happened is, I'm gonna redo here. This is kind of interesting. So this is a disk method, and it's this method. The reason why it's this method is if I'm gonna go from here, and it's going from here to here, right? We stop right here, and we're rotating around this red line here. And this is a red line. Now, it's rotating, so that means drawing axis rotation from here to this way. Is that a dx or dy? That's a dy, good. So if the dy is must be 0 to 2, and this is pi, is that okay? That's dy, right? Now is that disk or washer?
Just
It's gonna be a disk because you only draw to one line. You don't draw all the way to x-axis because there's no area there. The area is stopped at 2, so this is actually a disk. So disk, that means there is only one big R of y here. Now the problem is this distance kind of hard to earn because it's actually from here to here the black. So this is a black line, and subtract the green line. So black subtract the green. So black subtract the green is equal to red. Okay, so that's equal to red. Well, anyway, you know it's red. So then what you're gonna do is you're gonna take the black, which is 6, subtract the green, which is, I think it's y squared plus 2. And you had to put a parenthesis in that order and square because there was only one big R of square. It's gonna base on that. So this is a disk. Does that make sense? Now for you, I will use calculator, plug in all the answers, check the answer, see if it's right.
Why is it?
Okay. We're gonna do one more. Rotate around y equal to 5. Now y equal to 5 is kind of tricky because it's above x-axis. It's above x-axis. So rotate around.
What if you get one that asks you to rotate? Like,
It looks like it's
below?
It won't. I won't ask you that because that won't make sense. Because a lot of things is gonna repeat and it's gonna cancel each other out.
Is there a formula?
Okay, so this is a case that is a little bit different. So if you pay attention, I'm gonna erase this. Guys, be quiet. I'm still trying to teach you one more part. So y go to 5, so it's gonna be here. Is that okay? And this is the graph from here to here. Now remember, I draw it from the axis rotation. It's a dx or dy here. Dx is good. So because it's gonna go from here. Is that disc a washer? It's a washer, good. So the washer is gonna come from here. So I'm gonna use a black line here, represent here. So there was a black line and a red line. So we know this is dx. So it's gonna be 0 to 2, between 2 to 4. And there's a pi outside, but 2 to 6, sorry. Okay, so the bigger radius is a 5 square. Guys, I cannot talk over you guys. I need you guys quiet. I'm gonna teach one student for like next 3 minutes. So 5 square, right? Minus the red. But be careful of the red though. The red is the black minus the brown. Do you see that? The black minus brown?
So it's 5 minus root of 2. That's where.
Yeah. So it's gonna be 5 minus square root of x minus 2. Because this is the brown part, this is the brown part, this is the black part. And black minus a brown equal to the red. So this is the red. Square dx. Got it? And yeah, so you just learn all the rotation. This off-axis rotation, they're not exactly same rotations the other way.
Extreme this.
Huh?
Extreme this.
Yeah, I stream this.
You go back to the
No, you can use anything.
well,
Maybe one.
You need a test?